My dear computer friends, welcome back to Computer Guru VK Jain's computer classes. In this module, we are going to learn about analog computers. Friends, analog computer is a method of computation in which physical quantities such as voltage, current, rotation, pressure, or fluid flow are used to represent numbers and solve mathematical problems. Unlike digital computer, which process information as discrete binary digits, analog computers work with continuously varying values. Analog computer predates digital computer computing by many centuries. The first analog tool was slide rule. Friends, we used to have a slide rule in our college days, 1961 to 68. Slide rule was a valuable analog device on which, via which we are able to do the calculations. Although may not have uh, very accurate results, but some approximate details were possible. Then mechanical differential analyzer were developed in 1930. Now this 1930 business, I will show you. Electronic analog computers of 1940 to 70 of which I am talking. Modern application. Despite being largely replaced by digital computer, analog computer are still used in specific applications where real-time processing and continuous signal representation are essential. Examples include aircraft flight simulators, industrial process control, and teaching control systems in university. For teaching, the basic principle is in an analog computer, numbers are represented by physical quantities. Mathematical operations are performed by electrical, mechanical, or hydraulic components. The solution is obtained by observing the behavior of the physical system. Now, main components of an electronic analog system. Uh, we use operational amplifiers, register of different values used for scaling and summing. Wherever in any equation the resistance value comes, a particular resistor of that type, analog type, is inserted in circuit and results are seen. Similarly, capacitor used in integration and timing circuits. Potentiometer used to set parameter and constants. Function generator used to generate nonlinear functions such as sine, cosine, logarithm, exponential values. Sixth, display devices may be used like oscilloscope, meters, and plotters. Friends, this is one of the analog computer face interface through which we are able to generate the physical quantity by inserting our probes in these holes and then see the result here. Friends, some of the analog computers are shown in this diagram, of which slide rule was extensively used in the period 1960 to 70. then planimeter, then nomograms are still used today. They use they are part of our Indian standards also. So you have to select two quantity. There are three scales. You have to select any two. The third one is automatically selected. You have to just you select a value here and a value here and take that. You can see the result here. Then targetum, you can provide 3D spatial positioning. As Astro Lab, this this is a sort of uh, instrument which indicates directions. Then analog clock, of course, we use every day this type of clock, the wall clock. Then voltmeters, you must have seen. Ohm meter uh, showed you ohm value by inserting any of the resistances here, and the result is displayed here. Friends, something serious now. Application to hydro generator voltage regulation. Say I did my MTech from three institutions: MSCT Bhopal, HEL Bhopal, and IIT Kanpur for 4 months. 4 months in college, 4 months in industry, that is HEL. We have to go and learn practical design as they are doing. And then third one is you have to choose. I chose IIT Kanpur for doing my thesis work. So I took a thesis for studying a hydro generator, and for this hydro generator was simulated all elements of the hydro generator which were designed by HEL Bhopal. Now it is called BHEL Bhopal, and that was to be installed in UP, some project in UP, and I took that for my example. And that was having automatic voltage regulator, exciter, generator, and turbine governor system. Uh, I studied by making some transfer functions of each of these machines. A simplified AVR transmission. AVR means automatic voltage regulator. Function is often written as G AVR. Uh, some function is equal to K divided by K plus STA, where K is AVR gain, this one. TA is a AVR time constant, this one. TA, this one. These blocks would be interconnected on the analog computer through patch cards and operations amplifier to steady stability, overshoot, setting time, voltage response to disturbances. Friends, now we are discussing advantages and limitations of using analog computer. Advantage side, the analog computers are very fast for solving differential equations. Two, real-time simulation can be done. They have the capability. Third, no need for complex programming. And fourth, excellent for dynamic system modeling. Limitation side, uh, limited accuracy, typically 3 to 5 significant digits. Component drift and noise, difficult to store results. reconfiguration required for different problems. Every time you have to set the circuit contact equation and its constants. Less flexible than digital. Friends, now I am comparing analog computer with digital computer through some features. First is data representation. On analog computer it is continuous. On digital computer you have to feed number of data in discrete form, 0 or 1. Accuracy. Analog computer has moderate accuracy, digital has got very high. Speed for simulation. In case of analog computer it is very high, and in case of digital computer it is high. high. The fourth feature is storage. Analog computer very limited, digital computer large memory. Programming permanent memory we are talking about. Programming is done through wiring and patching and selecting different values of R resistance, L inductance, C capacitance, and for making it variable potentiometer is there. Programming in digital computer is done through some software. Reliability, the sixth feature, analog computer lower, in digital computer it is higher. Friends, thank you for listening me patiently and learning the items. Let me tell you, I'm VK Jain and I did my MTech from three different institutions. One of them was IIT Kanpur, and I did both digital programming and I verified the results obtained through analog computing also. So that way I learned both type of programming. Thanks for your patience.